So I don't know if you can see the picture on
Yes,
here. It probably looks like a flag of some sort. I can't picture which one it is. Japanese?
Yeah, Japanese have circle, don't they?
Yes, all of the flags I've noticed seem to be a picture of some sort. Not really sure. But anyway, never mind the concept of where this comes from, but it could be that the Japanese were onto something and they designed the flag. Just don't realise it until, you know, some people come here maybe on the planet, the plane, or whatever you want to call it, and just give off little clues. And then I think some of us are born then to join these all up and then pull, and then this all comes together and then dush, it all makes sense. I don't know if this will work because I can't test it. Well, I could test it actually, but I think I'm also going to just give this one away to any group that could benefit from it, and just let me know if it will work. Now, I've been playing with this concept and I don't know whether it will work, but I got a hunch that it will. Now, okay, so I'm just going to read these. So I either called it a frict gen or a statigen. Yeah? Like for static generator or a friction generator. Its power for spacecraft, when it spins in 0G, it will not stop and keep on spinning. Technically, that's not true. It will slow down eventually, but it's more likely to keep on going, yes? While this is spinning, the fibers will create static. This energy should generate power and a magnetic field. Maybe. There is also a clockwork mechanism in here and a motor. Now, the idea of this was, yes, that the motor, first off, winds the clockwork. The clockwork then throws the energy into this, getting this to start rotating. One is smack it on the side, but then I thought, how are you going to achieve that with it being contained? Because this is going to need to be contained inside something. So go imagine this as 3D, I think, like a ball and inside a box. So a box inside a ball is the best way I can explain this one. And as these have got lots of like feather duster type material on it. So it looks like a pom-pom.
Oh.
This is a meteorite, something very heavy and very large.
Yeah.
Or put this into smaller versions if it might start spinning the opposite way. It doesn't matter how this one spins, whether the outside spins or the inside spins. Either or, it doesn't really matter which one spins. I'm pretty sure that if this is bigger, this is heavier, this should spin more inside that, and the outside should stay stable. If not, then there's going to need to be some sort of, you know, the one where you throw something one way? In order to stabilize this and not use too much energy. I don't know whether there could be some sort of throwing arm going off. If this was on a bigger volume, a mass, such as a ship, and you had this broke down into smaller pieces on the ship, then it won't rotate the outside, because the outside of the craft will be too heavy. The mass of it will be too heavy for it to rotate, and therefore energy looks for the easiest route, such as electricity looks for the easiest way. It's the best way you can look at energy, finds the easiest way through. If it's easier to spin the outside, it will do. If it's easier to spin the inside, it will, and the outside will stay still. Attach this to something even larger like a ship, and you're taking in the mass of the ship, and therefore the mass of the ship outnumbers this in weight. Therefore, this has to spin, and the energy looks for the easiest way out, which would be to spin this. Now, once this starts to work, and this starts rotating off of this first wind-up mechanism, you will never need to use that motor again. And I think it's worth keeping it there, just in case. Because what will happen is when this starts rotating, is slowly but surely, every now and again, the bottom spindle inside here. So you don't even need to cut the meteorite in any way. We just need to clamp it to hold it in position so that it doesn't start moving all over the place and burst out the side or anything like that. And to drill into a comet is going to be very difficult. But it's possible that we could probably get into this using explosives or robotics extensions to go and drill into it. We don't need to go all the way in. We just need to make a little chasm in it, or a crater one side and a crater the other, and just hold it. And it will rotate. It doesn't even need to be a perfect circle either. It can be potato shape on its side and rotate that way. It can be an egg shape. It doesn't matter what size this is. As long as it's got the fibres all attached to it, and there are some fibres on the outside of it, I think that this constant moving will generate this static, much like a cat or a fox's tail or stuff like that. So, you know, I'm kind of getting the principle from there. And the way these fibres keep on flicking around each other, they'll stand up on end. And I'm thinking, not 100%, but possibly that this could start to generate some level of static. If this worked, and we made a few of these outside the planet, I was wondering whether we could generate a magnetic field over the planet using no electricity apart from momentum. Get one thing started. When you start to mount these up around the planet, I think that if we all got them to go in synchronicity around the planet, they would start to generate a magnetic field that might be powerful enough to stop the sun's energy from influencing. And if we do it too much, I got a funny feeling that things will start to freeze. It will start to become colder rather than hotter. So I think because you stop a lot of that radiation from entering the craft, too much of this, and I think you'll freeze. That's why it's probably not a best idea to make too many of these or too large, because we could overdose in magnetism. And just like the MRI machine, if too much is too bad, a little is good, not enough is not enough. So there has to be a fine balance in with this. But as this rotates, every now and again, it will send some of that energy into the clockwork to wind up the mechanism. Very gently, just now and again, just using that momentum. And then eventually when it starts to slow down, the clockwork can throw the energy back into the movement again. And perhaps it catches some solar rays, maybe some solar panels somewhere. And that can also power into the motor, because how fast could we spin it? Yeah. Therefore, with how fast we can spin it, does it create any gravity? Number one question I got. Number two is, how much energy does that create? Does it create more the more faster it goes and the more of these little tiny hairs interacting with each other? I mean, eventually it would slow down. And that's why I was thinking of the clockwork mechanism for now and again, just to sort of zoom into it sort of thing. And, you know, I'm sure that these little hairs, if they even touch each other slightly, it's going to take a fucking shit ton of those hairs to slow that weight down. I mean, you know, just them smacking into each other. It's not like here, where we got a bicycle wheel and you put your finger on it and it slowly starts to slow down. I think it's slightly different than that in space. I think that when you start to spin something, everything in this universe seems to want to spin. You know, it's all rotating, it's all whirling, water whirlpools and fire tornadoes, and in space it's rotation, synchronicity. So I guess it might align with everything else that's spinning. And this might become something where it starts generating a massive amount of magnetic energy, and that magnetic energy could be tapped into thanks to Tesla. And then therefore, do you see what I mean? Tesla came, and then these people came, and then this came, and then Japanese made their flag, and then you take all of those and you start to join them together, stitch them together, and then when you pull on the cord, everything all comes together. That's the way I'm sort of seeing it, that, you know. So, yeah, the clockwork is tightened by the motor. Once started, the motor and the clockwork will help to keep it in operation. And I did put full life there, but because I was just kind of running out, and then my pen broke. That's the funny thing about that, because I put the lid on the end of the pen, and I was writing with it. When I went to pull the lid off, and I tipped it up, and I looked, I was like, oh my days, the whole top of the... And because it's a paint pen, I thought I'd spilt it all over the sofa, which I didn't, thankfully, but... Yeah, so... I don't know. I do. I think this is something. I don't know what it is, but I'm just going with it. I don't know if this will work or not. Well, I got a funny feeling it will. Because it's generating static. And if you can tap into static based on Tesla's understanding, then there should be no reason why this shouldn't work. And yeah, I guess it's because I watched a video yesterday and it made me feel pretty good. So my gift back is this one. I will do a few more, because I got a few more with understanding how this all works myself. I mean, this is very new for me, and I don't know if it will or it won't. I mean, even if we had something that was potato shaped, and something that was more like a cup. Because, you know, I think this might cause wear and tear. But eventually, you know, we don't even need to, what do you call it? Do you see what I mean? You don't even need to drill into it. If drilling into it is absolutely impossible, then something more along this line. And we don't need any bearings or anything like that. I think friction will play a part eventually. But, you know, I think it will. What we want it to do is rotate. And if it starts channeling through the metalwork on the outside and starts finding its, you know, like the moon pulls the planet back and forth, and it might do that in the object that you've stored it in. It's possible that it could eat through this, so that maybe there needs to be some sort of bearings put into this bit here and this bit here to help it spin, rotate, if you get what I mean. Yeah. But grease doesn't work properly in space. That's the only unfortunate thing. So if you're using bearings, they require greasing, but grease takes on a different... So I guess it's going to need to be a bearing that comes encased with a piece of rubber, perhaps, and all of this is filled with oil, all of it, the whole bloody lot, to the point where there's no air in there. It's just 100% oil been injected into it, and hopefully, maybe that heats up the oil in there, and we can use that heat for something else. You can put that into something. Nothing should be wasted when it comes to space. And I mean, if this starts to rise up, this heat in here, then maybe we need to build some sort of device that can cool that, because it is space after all on the outside of here, and minus 350, that will cool the oil down. Or we pipe it in somehow and bring it into the craft and use the heat for something else, making more energy, warming you up. You know, you might as well use it, but I'm thinking the bearing should be more designed to sit in something more like this. And then if they had like a socket that holds it on the side here, and probably a couple that sit in here, just to make sure that it stays in place and it doesn't wobble around. Do you get what I mean? Just to sort of keep it secure inside all of that oil, and then it can probably freely move, hopefully with a good rubber seal around there as well, to stop the oils from leaking out, or whatever medium you want to put in there, water. I don't think it will work properly like that. But you never know, you might be able to make a water bearing based on some air-filled pockets instead, because NASA were playing around with some of that stuff made from mushroom, I believe, and it's quite a strong stuff. Also the US military. I can't be sure whether you were making some sort of bouncy castle material that is so strong that you can drop tanks on it.
Oh, wow.
It's inflated. It's very strong stuff. If you made some of those into some bearings, could you then get those inside one of these and put some water in there instead of using oil, and then it rotates inside the... Do you get what I mean? A new type of bearing system in space would be different to what you'd have on Earth. And then you don't need any grease. It can pop and get hot. Also, a braking mechanism, and these will need to be able to, if they started going AWOL, to be able to be jetted off the craft. In case it starts doing something, like a wash machine starts bouncing around the, you know, when the arms break or something like that, to maybe push this away from the ship very quickly on an emergency, blow it off. And as that happens, whatever it might do out there is off the ship then. Because if not, that could be a catastrophe if this decided to start a tornado in and then it pops out the side and then crashes through to the ship and breaches the hull. You'll then have catastrophes all over the place. And this idea then, you know, they say that you shouldn't think negative, but unfortunately, if you don't think negative, there could be an accident happen later on and down the line, and that fucks humanity up in the long run, because, you know, I'm just trying to think of a way of making energy. It's easy in space. It's difficult on a gravity environment. It's easy in space to generate energy than it is on your own planet. So you're going to burn through all your fuels no matter where we go and what we do. The clockwork power, yeah, this one is using an MPPT booster rather than the MPPT charge controller, which I got that wrong. Now, if you use an MPPT charge controller, so the magnetic energy of the MRI, or a crane from a scrapyard. Do you get what I mean? The ones that you pick up the cars. It's like almost a ton's worth of...
yeah, it is.
It can lift that ton. Well, if you took one of those electromagnetic plates that they use, do you get what I mean? It's on the... And this worked, the clockwork mechanism, and we put it on the floor instead. Yes? And when this energy comes on, all of the chains from the clockwork get pulled down towards it. Yes?
Yeah.
And then, once all of this gets pulled down based on this power, it then stops its magnetism and we turn it off again, just like it wants to drop the car. And then these start going... Whilst another one is then pulling down and... This energy then is, the clockwork mechanism is then really fast. We're not on about a clock, we don't want to measure time with it. We want it to go as fast as it possibly can. I had this little clockwork mechanism when I was a kid. Nice blackbird. I had this little clockwork mechanism when I was a kid, and when you removed certain things from it, when you wound it up and let go, fucking hell, did that spin. It went really, really fast, and we tried to get it to go faster by doing something with the spring, putting a different type of metal in there, I think it was. This one was a metal one that got wrapped around something, so we changed that, and it got even faster. So, with that mechanism that flies off on there, if each one of these clockwork mechanisms went into a giant flywheel, and it started spinning that, and then that flywheel was then connected to a load of gears and cogs and mechanisms that then went into turbines, lots of turbines. Then there could be enough inertia off of there and power from the gears. And if you've got 2, 3 or 4 of these working and letting go at the same time, that flywheel, should just keep on flying and going and going and going and putting this into the motors. And I think it would be an awful challenge for any turbine to try and slow that down. I just don't think it would work for it to try and slow it down. Then off of that energy that comes out of those motors, boost it through an MPPT booster charge controller. And then I would be inclined to throw that then into a charge controller and then into a... There's that way. This could work on a ship too. Once that wheel started moving, I mean, the same mechanism can get this to rotate.
Yeah.
And then you could, in fact, put some motors in here as well and get a little bit more uses of your energy. I'm not sure. That could slow down eventually, that one. But it's unlikely, depending on if it's bigger than your motors. You think how big a wind turbine is. To us, our perspective, it looks pretty big.
Yeah.
But some of these meteorites out there that are in the Kuiper belt, asteroid belt and all of that are very easy to get to. They're not all clumped together like everybody first thought. They're really spaced out. It's just sitting there quite calmly, actually, not quite as violent as we think. If we were in the perspective of the universe, then everything's happening very fast. Yeah. But we're not, so our time warp is a lot more than the universe itself. But like for like, we're all on the same time scale. Like for like heartbeats as well. It's a beautiful bird. We got lots of birds here. They love the food, don't they?
They do.
Yeah. Yeah, what else I put? So fibers A, fibers B, comet or large heavy object. A place to hold it in place. These ones are the ones that hold it in place. Center, column, clockwork mechanism, motor. I think I've covered most of it on here just for now. Hey, it might not work, but I just don't see why it wouldn't. This one seems to be the most logical way, to be fair. And then, I'm not sure whether once that starts rotating like that, and we're taking the static from it, yeah, I don't see it slowing down because we're taking the energy. You know, much like a fan or a wind turbine, they really need to try and... I find that strange. They need to do that, but they really need that resistance of the wind to pull it and the muscle of the wind to really... This is a different type of way of taking energy and making it. You're not using that rotation. You're using the byproduct of the rotation. Yes. things want to rotate in space, don't they? Take a look around.
They do, don't they?
Yeah.
At least that's what we are told.
Well, once it gets going, it doesn't seem like anything wants to stop.
Yeah.
And some of the comets that come flying over, some of them I've seen, very quickly, I was just looking at the sky at the right place at the right time and just bang, fucking as quick as that. But at that time I was kind of taking it in snapshots, and this thing is rotating very fast. It's like corkscrewing as it's flying. When I saw that, I was out the window in Griffin, and I saw that. That was huge. That was freaking massive. And I sit there and think to myself, if that had hit us, that one would have been a clipper. If it had just been a little, I don't think it hit through the atmosphere. I just think it was just very quick that I saw it and it disappeared again. As quick as I saw it, it was so fast that I really had to slow it warped. Something warped slowly enough for me to capture that. Yeah, so things definitely want to. I mean, once that starts to get going, I mean, how would you even try and slow that down? Because it's the weight, it's the mass to try and capture something like that. And then you would be harvesting big chunks of very dense. A piece of black hole would be nice. If you had a black hole, and they say that a teaspoon is like 1,000 tons in mass. Yeah. Well, let's say if we were able to physically, if it was possible, to take a piece of the black hole, do you think of how much weight would be inside a CD's worth? Oh. And then you add it into this sort of process. Do you see how the energies can really start to get going? So that'll take a lot to slow that down. Once it got going, that wouldn't be the problem. It would be slowing down. Once that started spinning, you wouldn't technically be able to stop it. Because as soon as you went to grab it, everything else would start to rotate around it. So I think it's very best that if you're done with a device like that, is discharge it and just leave it. And try and slow it down from a distance, not anywhere near the ship, because it could be catastrophe, and it needs to be a long way from the ship before you even tried anything, just in case it altered its course. I don't know, knock it here and it could just catapult it. Who knows? So yeah, as much as space can be fun to float around in, yeah, I think the answer is up there. I think, most beings would hover in space. They wouldn't live on a rocky body. I think for lots of reasons. Number one, the genetics inside your makeup and your body, animals and humans will change. We'll probably turn into something that looks a bit similar to an octopus. Eventually, most of us will go that way. The evolution will go the same way for all of us. That's when you uniform, I think. You see, on Earth, we're all in different areas, different climates and different foods. Plays a part in evolution and the way your body is going to change and adapt to your environment. But in space, when we take all the animals up and all of humans up, you will then start to, across the board, similarly eat the same stuff, act the same way and be the same way. And as this starts to happen, I think the changes to the species across the board will then, for the first time in history, will then begin to become like uniquely the same, eerily similar. So I think the first changes, because by then you need a one world situation. You need you can all have your different bats and different things like that. I told you it was the third stuff you wanted, not the first. Not the second. It doesn't matter what people take on the first or the second stuff. It does matter, but it's this. And I haven't released any of this information. I kept this under my hat for a while. And there you go. Like I said, when other people are looking down there, you be looking towards this sort of stuff. And this gets you exactly where you want to be very quickly. And yeah. So, I think this is the winner for all of us, for everyone. This then gets everybody. I think what you'll see is everybody will rush to space. And then I think then all of the governments will then have a real challenge to build. And I think that the demand will be so great that I don't think there will be enough building. I think that everybody will just roll their arms up and just start building. I think that's what will happen. And then this can happen within our lifetime. Mm-hmm. This can happen within your lifetime. Kennedy set a challenge of 10 years. And I'm pretty sure that within 20, less than that, I think that this could already be half completed. And people start ferrying off the planet. And then you've got what, 50 to 80 to 100 years worth of carbon fuels burning or fossil fuels. Well, the holiday will then be go to Earth, go to Mars, go down on the rocky body for a bit, and and then as a whole, where are we going to go? Oh, I don't know. Should we journey around the solar system and stuff? I think it's best to scout first. You need scouter ships. They go off and scout because you could get too close to Jupiter in these scout ships, and unfortunate as it may seem, I don't want any fatality. But at the end of the day, if you can't prevent it, an ideal world or life would be no fatalities. But if the scout ships went out and it was something like Jupiter, something happened to the scouter ship, you'll know not to take your mothership there, if you want to call it that, and or your Earth ship or whatever. So you probably wouldn't go there as a group because of the scouter ship was too much. So. Mm-hmm. And then as you start to bottleneck around, and we also need these scouter ships to be like tugs. So let's say we take the big ship over to Jupiter and it gets stranded there. For whatever reason, maybe something happens. These smaller ships the scouter ships need to be able to tug the craft back to Earth, back home. Mm-hmm. One way or another, they need to be able to pull it, push it, move it, nudge it, and then back to the drawing board once we got it closer to Earth to figure out what went wrong, blah, 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 everybody comes down sort of thing. There's going to be a lot of trial and error, but I think, personally, that once it starts, it will be like a new apartment. It will go smoothly as that, I believe. And then having lots of these on a ship, one goes one way, one goes the other, one goes down, one goes up, one goes left, one goes diagonal, like a chessboard. One covers each spin, and one covers the opposite way of that spin rotation. And then the next one spins this way, and then the other one spins that way. Then one spins on the slightly diagonal. You want to try and make it much like the star, that it's all spinning in all directions. So you want it to be spinning this way. This is good. Mm-hmm. You also want one to be spinning this way. You also want one to spin the opposite way. Uh-huh. You want one to go this way, that way. So each one of these should be a spin one way. This should be a spin in the opposite. Then this one in a spin in this trajectory. This one in a spin backwards, that way, and then this way. So then you cover it like a clock. On each side, you have your yin and yang. One goes forwards, one goes backwards. One goes up, one goes down. One goes left, one goes right. And I think if you had this built onto a ship, you're then going to stop all of this, because if you spin it and the outside might spin, and that's no good for humans because you won't be able to stay on that if it exceeds past 4G. Yeah. And then you might be able to make some sort of gravity from it. Perhaps. And we'll see. We'll see. But, yeah. So I'm going to give this to you. Any groups that are watching or behind the scenes, different stuff like that, I'm going to give this to you. Have this one. Try it. I don't know. Maybe what have you got to? You could build this in a small model and see if it even does anything. And if it does, then, well, hallelujah. Because then we have something. It's not great. It's not Earth. And it's not a new type of fuel of any type. But what it is it's something. It's another step. It's not run out and all go back to the Stone Age. No, far from it. It's another way to venture off and all things come together and land on this mass. And the energy is then just pushed through. What I was thinking was more so, I'm going to be building these in the next coming weeks anyway. So, I don't know. You want to loan me something? And I'm going to go away and build some stuff that I'm going to try it here and see what happens. And then if that works, then I'm going to add it over to this because it will then fit into this where, I don't want to go into it just yet because I don't want to jinx it. Yeah, do you get what I mean? Mm-hmm. So, but for now, if this one works, then there's Yeah. I just don't see why it wouldn't. There's a lot of energy brought up in these. I'm pretty sure this is gonna, some way, somehow, or something is gonna come from it. Maybe nothing. Maybe there's not enough energy come from that, or maybe there's no way of translating that energy from that static energy. I'm pretty sure that energy is energy, electricity and sparking, and maybe it doesn't give a lot, but maybe it gives enough to do this, this, and this. Maybe not. Change the process, and if you have something that's hot, molten in there, around the outside, I just find it very risky to start with. I think as humanity we need to be able to start with something basic and understand the concepts first, that isn't radiation, that isn't hot where it could melt through, and you know, if this was heated and it was all sparking out, we were getting the magnetic field from that, which is very good. What happens if it breaches the hull?
Yeah.
Or it goes crazy and then it'll eat you. It'll eat the whole mass, will just shrink into it like a piece of big plastic that when it burns, it slowly but surely starts to just, that's what will be like the ship if it goes wrong. And I think this one gives you a little bit of understanding. It paves the way, or blazes a trail for what to do when you learn this, learn that, learn this, learn that, and then, okay, are we ready for some hot stuff in there now? Can we now manipulate that? Yes. Okay, then this gave us all of that, what not to do, and I'm sure there will be some problems come about. And this one will probably give us all of the, I'm not sure what I'm seeing, I'm just seeing a lot of friction. And then depending on how big it is and what type of fibre you use, I'm pretty sure that can generate static. Another one was 2 sheets together. This one does require some energy, but as they flap towards one another and smack each other, they create like a static. There was this static sheeting that I was going to use for the wind, where you take 2 very highly, where you feel all of that static on your arm. When you touch it, there's like loads of this blue lightning happen. Well, if you had 2 sheets that were blowing in the wind, sort of smacking into each other every now and again, they're in close proximity, they couldn't be too far apart, but they can move and move with the wind current. And as that happens, they create this sort of static. You know how it works? The static starts to build up because they've got nothing to, and if it's up in the air and they're on like wood and it's not, it cannot discharge that. It's going to do 2 things. One, it's going to be low enough to create lightning on the ground from this. Yeah, it's going to discharge that way. Or energy looks for the easiest route. If we ended up putting something into there where we can transfer that energy into using it for powering our stuff, then it will choose to go that way because it's easier. And anything extra that was being generated in that would then discharge straight into the earth. So it wouldn't blow anything up if you couldn't use the amount that it was making. So that was massive pieces of plastic that covered over the ocean. They were transparent so that they didn't cause any shadowing on the ocean. They were good enough of reflective that they actually went this way so that when they were moving, hopefully they were refracting some of that light back out, like snow does. You know, it bounces the light off back into space. And I was wondering whether this over the ocean, it wouldn't cause it to shadow the sea to create algae blooms. It wouldn't hamper the wildlife. And these sheets just sit there, just bashing out in the sea. Hitting into each other mainly is the objective that you want them to do, to create this type of frictiony static that they do. And yeah, the same thing might work in that situation. I am not 100% sure though, but one thing I do know is Steve used to work with this company that was like Ultrafilm, I think it was called, and he bought some of the sheeting. And what was it? It was going to be chucked and reject anyway. So Steve asked for it, and what he was going to use it for was wrapping paper, which was a fucking brilliant idea, to be honest, this stuff. So that's what he used it for. But when he had some of this stuff, I couldn't help but notice the amount of times I got belted off of it. Like quite a long sheet of the stuff. And then we had this other thing where you could run and slide on this water mat. It was like the length of our garden, and we had 2 of them, which was bought from a shop, to be fair, and you can go buy it on the reel. Well, we had a couple of those, because one of them, after sliding down on it, lucky to be honest, but it wasn't that bad, a piece of flint might have jagged it. I don't know, or the dog's chewed it. We don't really know, but we're going to take it was a piece of flint at the time, not to blame the dog. And we had to get another one of the sheets because, you know, they don't want to slide in and go underneath the sheet because of the slight tears in it. Or it could have just been when we folded it up and just threw it in the shed one season. You know, a long piece of plastic that you wet it up, throw a load of washing up liquid on it, and then you go run and slip and slide down it. And it's quite fun. That's what we were doing. But anyway, after that, there was, when unravelling it and it was dry the first time, it would electrocute the shit out of you. So we had to put it on the ground and try and kick it. And that saved you from getting electrocuted because it discharged into the ground. But my word, your hair stands up and every part of your arm is feeling it. You can sort of feel it, this sort of energy, you know. And yeah, I was often wondering if that energy in there was enough to hurt me. Is that enough to generate something? Because it feels like I've just been shocked. Energy is energy. That's definitely generating it of some type. But anyway, so yeah, let's see if I can get that put in there like that, maybe.
Yeah.
So that if you had like 2 sheets, yeah, maybe 3, and they were attached to some, I don't know, pile or whatever, and they were not able to be earthed, yes, and then these piled nicely in the ground somewhere else, under the ocean, or perhaps the ocean or river or whatever. Every time the wind blows, it will cause these sheets that they're not too tight enough to be torn, and they're not slack enough that they're touching, but the slightest breeze will cause them to smack into each other and generate this build-up of static in here.
Yeah.
And then I'm wondering whether that static, once it built up too much, would start discharging onto the planet, or we take it as energy from that. And, you know, no one does anything with the ocean anyway. It's in the middle of nowhere. If it's transparent, the light can sort of still get in, but it can also have a chance to bounce off a lot of the light. You see, and the higher up these go, you know, the less chance of discharge into the ground, and you're going to be above the carbon layer. So global warming seems to be, I don't know, a situation where they say the greenhouse gas effect, whether true, the light comes in and it gets trapped underneath the radiation, or the heat radiation comes in and it gets trapped underneath the carbon before bouncing. Some bounces out, not all of it. Well, if that be the case, then if we were to build this above all of that, we've got a high chance that we can reflect a lot of that heat and light before it gets under the carbon to create the greenhouse effect. And some light will filter through, obviously, but not as much. And then therefore the ocean won't get as hot, therefore the polar caps stop melting as rapidly, and then maybe there can be some level of energy come from this. I mean, how big is the ocean? It covers more than the landmass. If we converted this into a type of plastic-y, sheety, or feather dustery type of stuff, I don't think that one will work on the Earth, but it might. You can still create some sort of static-y and magnetic-y type of sticky situation-y, I'm not really sure what that is, to generate something. It's another way. Maybe it doesn't make enough or a lot. Then, okay, fair enough, it didn't work. But, or maybe you need ridiculous amounts of it, I don't know. And maybe the same be said for this. I don't know. If this works on a small scale and you get the understanding, you could then probably use more molten stuff when it gets heated and it starts to then tap into it that way. So, I don't know. Maybe it works, maybe it doesn't. There you go, I'm going to leave it there. So that's my video for today.